Yeah. Please confirm my audibility, Achyut. Achyut, good morning. Achyut, please confirm my audibility once. Am I audible, Achyut? Achyut, please confirm audibility once. Yeah, I'm audible clearly, right? See, in this session, we are going to solve 2023 HPCL questions from the branch of electrical engineering. तो इलेक्ट्रिकल इंजीनियरिंग का क्वेश्चंस जो 2023 HPCL पेपर में दिए हैं वो वाला क्वेश्चंस हम ये वाला सेशन में सॉल्व करेंगे. सी yes, any questions you can ask before I proceed, or when I am proceeding also in the chat box you can uh, post your questions. If you have any query regarding any question or concept, you can post your question. Yeah, yes, Achyut and Harika. So keep posting your questions or answers for the question. Before I proceed into the HPCL paper, let me tell you a few points. In HPCL paper, since last 3 years, the very important subjects for electrical engineering are networks, EMFT. Yes, I was stressing the same point since long back, same point again and again, but because many people will take EMFT as a light, means they will not go through it, but EMFT is damn important. 10 to 15 questions they are asking from EMFT. In EMFT also, again the questions are very basic questions like what is curl, what is divergence, what is ampere circuit law, very basic questions. You need not to dive in depth, right? So very basic questions, but covering all the corners of the subject is very important. Okay, whatever that is there in your electrical syllabus, okay, that is enough. That is enough. You need not to go beyond that, right? You need not to go beyond that. Then after that, electrical measurements, power system, electrical machines, power electronics is also very important. See, power system is a very big subject, electrical machines is a very big subject, but the questions from power electronics are equally in number when compared to machines and power system. From power system, suppose 15 questions are coming, from power electronics also in some paper 15 questions are given, right? And though mathematics is officially not mentioned, but some questions from mathematics also they are giving, that is especially from the area transformation theory, Laplace transform, its advantages, or how Laplace transform is done, those things, right? So these primarily very important subjects. From analog and digital, one question may be asking, may not be asking, sometimes they may ask 3 to 4 questions also. So overall the subjects are, I can say, network. From network, damn sure I can say some 10 above questions only will be asked. 10 above questions, not less than 10, not less than 10. Okay, next one is, I can say, EMFT, power system, yes, machines, electrical machines. Next one is power electronics, yes, measurements, in fact electrical measurements. Then miscellaneous topics like analog, digital, some questions from mathematics, basics of mathematics, some questions will be asked. Okay, now let's enter into the very first question that was asked in 2023 paper of electrical from HPCL. All of you read the question. I'm reading the question along with me. Please look at the question. A step down DC chopper has a resistance load of R is equal to 15 ohm and input voltage of EDC is equal to 200 volts. When the chopper remains on, the voltage drop is 4.5. So that fellow says is, yes, what he's saying is, carefully, voltage drop is 4.5 volt. Voltage drop is 4.5 volts. The chopper frequency is 2 kilohertz. The duty cycle is 50%. Determine the average output voltage. See, voltage drop is 4.5. Then how much voltage will reach to the, I can say, towards after the I can say after the drop, how much voltage that is reaching, that is 200 minus 4.5. So I have to take V input as 200 minus 4.5. It will be 195.5 volt. How much it is? 195.5. First of all, what is a chopper? It is a DC to DC converter. Chopper is DC to DC converter. Now is asking what is the average output voltage when the duty cycle is 50%. Yes, V naught is equal to alpha times of V in. This is V in, please. This is V in. What is alpha, sir? What is alpha? Yes. For how much time it is on? T on by T on plus T off, total time. T on plus T off, yes, into 195.5. So this is very important. People will take it as 200 here. No, you have to consider the drop. If you remove the drop, then you are getting 195.5, right? So V naught is equal to, so this is nothing but your duty cycle, in fact. How much it is? 50%, that fellow given. So 0.5 into 195.5. Tell me how much is 195.5 into 0.5. Yes, calculate it and tell me, please. Yes, Achut, Harika, please post your answer in the chat box. Please post your answer in the chat box, please. Yes, yes, yes. Come on. Achut and Harika. Yes, it is. Harika, I think you typed it wrongly. It should be, yeah, Harika, you, yes, it is 97.75. Yes, 97.75. Yes, I'm putting the options here. The option is A, B, C, D. Or HPCL examination paper, that fellow is giving 1, 2, 3 instead of A, B, C. So option is B here, B for Bombay. Option is B. Simple question. But you see, one must have the idea of chopper, then it is a step down chopper, then considering voltage drop, then having the idea of duty cycle. These things are very, very important, right? Let us go to the next question. It's a very easy question, theory question from measurements. The previous question was from power electronics. This is from electrical measurements. What is saying? I'm reading the question. The portable instrument which is generally used for testing of insulation resistance is an insulation resistance tester is dash. So simply, he want to test the insulation resistance level. See, if this is an insulation, how to check its value or level and value both, that's it. How to check its value and level? You do one thing, connect voltmeter and ammeter, take the voltmeter ammeter ratio, that is going to give you the resistance. There are different ways of finding resistance. The first one is, I'm listing voltmeter ammeter, or yes, ammeter voltmeter method. Yes, in measurements you will come across this one, voltmeter ammeter method or ammeter voltmeter method. See, Abhishek Kumar given answer yes, correct. We'll go there. But see, I'm not just discussing that question, I'm discussing the concepts which are in its periphery. Okay, not just that question. Okay, listen. So this voltmeter ammeter method or ammeter voltmeter method is used for finding which resistance. Resistance is divided into 3 parts: low resistance, medium resistance, and high resistance. Low resistance means less than 1 ohm is low resistance. 1 to 1 kilo is medium resistance. Greater than 1 kilo ohm is high resistance. Okay. Now, voltmeter ammeter or ammeter voltmeter method is used to measure medium resistance. And there is one more method called substitution method. Yes, substitution method. This is also used for medium resistance. There is another method called potentiometer. Yes, potentiometer. In HPCL question is not asked, but potentiometer is a very good concept. That is also for medium resistance. You can use Wheatstone bridge also. Yeah, some question. Tarun Meena. Sir, how to prepare HPCL along with the gate preparation? Mr. Tarun, the HPCL preparation is completely different from gate. Okay, please don't mind. I'm saying like this. HPCL preparation is 100% completely different from gate preparation. Why? Because in HPCL, the important areas for the examination are the one which are not important for your gate. Suppose if you take a power system, in power system, power generation, distribution, and I can say power system protection, economics of generation. These four topics are not at all important for gate. If you want, you can leave those topics for gate examination. Tarun, okay. But for HPCL, from these four topics only, all the questions will come. All the questions. If you check the last 2021, 2022, 2023 paper, these three papers, if you see, in all these three papers, no question has been given, no good question has been given from the areas like fault analysis, which is important for gate, and stability analysis, which is important for gate, and load flow studies, which is important for gate, and transmission, especially classification of transmission lines, steady state performance of transmission lines, transient analysis on transmission lines, voltage control, right? From these four areas, no single question was given in these three papers. So please do not combine your gate preparation with HPCL preparation. The preparation should be completely different. Your gate preparation, you must be logically minded. You must have depth analysis for gate. Suppose in gate, for example, one question is given like this from power system itself. In power system, one question is given. The question is from fault analysis. That fellow will give total data. From that, you have to think a lot. That is not from your memory. You have to do, I can say, iterations. So this way I have to approach, that way I have to approach, I have to apply this formula, that formula. Okay, this is looking like data is not sufficient, then from where I have to get the data required. That way you have to think. But for HPCL, simply your memory and few formulae, that's all. Tarun, okay. Tarun, I hope you got my point, right? Yeah, come here. So these methods are, there are few more methods, we are not looking those methods. Medium resistance. Then now, how to measure low resistance? Yes, you have Kelvin's double bridge. In fact, I can use Wheatstone bridge also for measuring Wheatstone bridge also for measuring this medium resistance. This is medium resistance. Medium resistance. But for low resistance, yes, Kelvin's double bridge. What is that? Kelvin's, yes, double bridge is used. Kelvin's double bridge. Now, for high resistance, none of these methods are useful. If you want to find the value of high resistance, as the resistance value is high, you can't go for ammeter voltmeter method. Why? Because you must give a lot of voltage for the small amount of current to flow. That's a lot of power loss is going to happen. That's why we are going with these methods. See, methods of high resistance measurement are, for high resistance measurement, the first method is Megger. Yes, Megger is an instrument. It's an hand-driven generator. Yes, it's an hand-driven generator. You're carrying with you. You rotate it with force, then it will generate EMF. That EMF is applied across that high resistance. Now then current will flow. So that ratio will be taken. See the way, how simplest way I'm telling, not the complete way of how Megger works. So Megger is one method to find high resistance. Second method is loss of charge method. Loss of charge method. And third one is, yes, loss of charge method. Yes, Megger, loss of charge. I can say, yes, those two are enough for us. Those two are enough. Megger and loss of charge. Right? These are the two methods which are used to find the value of high resistance. Okay, there is another method called direct deflection method, which is not required for us, but you can remember the name. Okay, so Megger and loss of charge method. Right? Let's go for the next question. Yes, this is the question for a transformer, though he is mentioning it as a outdoor distribution substation, but this question is from the concept transformer. Transformers is very, 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 very important. At least 8 to 10 questions will come from the concept of transformer itself. The important areas of transformer are construction details, materials. What are the materials used for core, CRGO material, cast steel, cast iron, different materials. Knowing about those materials, construction, working principle, tests on transformer, oil in the transformer, tests on. We are going to conduct SC test and OC test. Some other special test also, tan delta test to find the insulation. Right. Very basic questions will be asked, but those phasor diagrams of transformer also. Simple phasor diagrams, don't go too much complex. Phasor diagrams of transformers and efficiency of the transformer. A single phase transformer and three phase transformer, right? Yeah, observe here. So somebody answered it. Yeah, Harika already answered the question. And who is another person? Kumar, Mr. Navlesh Kumar also answered. Some outdoor distribution substation transformers are equipped with a tank on the top of the transformer called dash, in which expansion and contraction of the oil takes place. Conservator tank it is. Direct question. See, what is the purpose of conservator? See, what is, first of all, what is the oil that is used in transformer? This is also a question a lot of times asked in many examinations. Many times asked in many examinations. That is, what oil is used in transformer? Synthetic oil or mineral oil? Okay, the oil used in the transformer is what? Synthetic oil or mineral oil. And what is the purpose of the oil? Oil will serve two purposes. One is it is going to provide cooling. Yes, it is going to provide cooling. That is one purpose. Another purpose is it is acting like an insulator. Yes, it is acting like an insulator. It must have good dielectric strength, right? But whenever load increases, especially in summer season, load increases, then current in the transformer winding also increases, right? Then lot of loss takes place. Power loss, I square R loss takes place. That I square R loss is getting dissipated in the form of heat. Then the oil in the transformer will experience some forces on it. Therefore, oil expand and contract. For that one, we have to provide some space. That space is provided by conservator tank. That space is provided by conservator tank. Okay. So there are a few more things about the silica gel is used in the transformer to avoid enter of moisture into the transformer oil. Okay, silica gel is used. Bushings are there for transformer. So knowing about each and every equipment of the transformer is very, very important. Okay, but for gate, no, you need not to know about conservator tank and all that. No one is bothered whether you know about conservator tank or not. But you must know, like see, the questions in gate examination will be like this on this, especially for transformer. The fellow will give like this: if the material that is copper that is used in the transformer, core that is used in the transformer is some x kg. If I'm volume is this much. Now, if I'm reducing the volume to exactly half, then the rating of the transformer is reduced by. So this kind of some innovative questions will be asked in the gate examination. Satyam Sinha, silica gel has blue color and used silica gel is pink, right? Good. See, Satyam Sinha, this kind of things only you have to learn for HPCL examination. Next, yeah, this is also theory question. Though the answers are numericals, but the question is theory. Read the question carefully. What is saying? In a potential transformer PT, the secondary winding is designed so that voltage of dash is delivered to the instrument load. Tell me, what is the purpose of PT first, potential transformer? CT is going to step down the current. PT is step down the voltage, potential transformer, right? So the purpose of PT is to reduce the very high voltage to low voltage potential transformer. So it is going to deliver, yes, options. Anyone of you know the answer? Here, no logic, no magic, just you have to remember that range. Practical range it is, practical range. You know, CT ratio will be 400 by 5. Primary current is 400, then secondary current will be 5 amperes. Suppose if primary current is 800, secondary current will be 10 amperes. CT, general CT ratio is 400 by 5. CT primary is 400, secondary is 5. Another is also possible, that is 400 by 1. So these are the standard, but this is more standard. Either of these two will be given in the examination. Okay. So Harika saying option is 1. Yes, very good, Harika. It is 100 to 120 volts. 100 to 120 volts. Please do remember this one. Right? See, The purpose of solving this previous paper is to make you understand what kind of questions has been asked previously, and in what direction you have to prepare for the next upcoming HPCL examination. That is the main purpose. Okay, yeah. Read the question. Which of the following is correct regarding distribution transformer? He is asking about distribution transformer. Read it and try to give your answer, please. Distribution transformer. You know, transformers are of two types. One is power transformer, second one is distribution transformer. The main difference between power transformer and distribution transformer is power transformer is always loaded fully. Its load on the power transformer is always constant. 99%, 99.99% of the time, load on the power transformer is constant. Listen to me carefully, this point is very important. If load on the power transformer is constant, power loss is also always constant. Then we have two types of efficiencies. Efficiency, see, tell me which efficiency we have to find. See, efficiency, anyone can type in the chat box, yes, Achut, Harika, or Tarun Meena, or Satyam Sinha, or Navalesh Kumar. Yes, anyone of you can type in the chat box. Yes, what is efficiency formula? Efficiency is output by input, but here two things are possible in electrical engineering: output energy by input energy, or output power by input power. So generally efficiency means what we have to take: output power by input power, or output energy by input energy. We take mostly output power by input power. Why? Because we are assuming that load is constant. If load is constant, loss is constant. If loss is constant, then either you take output energy by input energy or output power by input power, the value is going to be same. Yes, but for distribution transformer it's not like that. For distribution transformer it is not like that. Distribution transformer load changes. See, efficiency, the basic formula of efficiency is output energy by input energy, but energy is what? Power into time. Output power into time by input power is nothing but output power into time plus loss into time. Loss of power, power lost, power loss into time. The T will get common. Why? The amount of power is fixed with respect of time. Therefore, if it is working for 24 hours, T is 24. Therefore, output power by output power plus losses will be the efficiency. But for distribution transformer, it is not like that, because this is the basic formula. Output power. See, output energy I am taking. Why? Because output energy plus loss of energy is not same with respect to time. First 1 hour load is very high, power loss is very high. Next 1 hour load is decreased, power loss is decreased. Next 2 hours power is moderate, load is moderate, power loss is moderate. Therefore it is changing. So loss of energy you have to take, that is keep on changing. So all that summation you have to take from, suppose here output energy you are taking for 24 hours, here 24 you can put, means see, energy na, power into 24 you can put, power into 24 you can put, but here you can't put into 24. 24 will not come output in the I can say formula. Therefore you have to find output energy by input energy. That is called as I can say we have two efficiencies I told. No, one is energy efficiency, another one is power efficiency. For power transformer we find power efficiency, but for energy, for distribution transformer we are going to find energy efficiency. It is also called as all day efficiency. Yes, please do remember the name. See, we are finding efficiency for distribution transformer is energy efficiency or all day efficiency. For power transformer we find power efficiency. For power transformer either you find power efficiency or energy efficiency, both are exactly equal. But for distribution transformer both are not same, and in fact power efficiency is not correct. Why? Because the load power on the distribution transformer is not constant with respect to time. Therefore we have to find always all day efficiency or energy efficiency, right? Yeah, now that is a small explanation about the difference between power transformer and distribution transformer. Yes, read this question please. Which of the following is correct regarding distribution transformer? Distribution transformers connected to primary system 2.4 to 34.5 kV to the secondary system 482 and lower. Yes, this is very much correct. We have two types of distributions: primary distribution and secondary distribution. Primary distribution will be of the voltage up to I can say 33 kV, 11 kV. But secondary distribution is from 11 kV to 480 or 230. right? Single phase 230, three phase 480. Line voltage is 440 to 480. In between, yes, that is line voltage. Phase voltage is going to be 230 volts. So distribution transformers connect the primary system, yes, primary system to 2.4 to 34.5 kV, to the secondary system 480 and lower. Yes, it is very much correct. Yes. Next statement. Distribution transformers may be installed outdoors on overhead poles, pole mounted, outdoors at ground level on pads, pad mount transformers, indoors within buildings or underground in the manholes and walls. Yes, yes. Sorry, this is not correct. Both 1 and 2. So distribution transformers can be, you might seen pole mounted, pad mounted also you can see, and you can observe in the manholes downside also, inside the earth also, those can be I can say installed distribution transformers, right? So both the 1 and 2 are correct. Next question, you see, very good question, very good question. See, yeah, none of you answered the previous question. Achyut, Harika, and Abhishek Kumar, Tarun Meena, and Satyam Sinha, please. Yes. Next question. This question is from network analysis. Network analysis. Which of the following equation is correct regarding the following circuit diagram? Just he is asking KCL. Yes, he is asking KCL at node A, node C, and node B. KCL only is asking. Let's write at node A. Let's write at node A. What KCL says? What KCL says? KCL says that, yes, what KCL says? KCL says that sum of all the incoming currents is equal to sum of all the outgoing currents. This is one way of understanding KCL. Another way of understanding KCL is total current at a node is equal to 0 at a node. Why? Because node is not a storage point. Node is not a storage point. Water that is coming, that must leave, or water that is leaving, that must come. Both are correct. Yes, water that is coming, that must leave. Or if something has to leave, then that much first must arrive there. Both are correct. Node is not a storage point. Therefore, net amount of current at a node which is getting stored at a point is 0. Sum of all the currents at a node is equal to 0. But current is having direction. We have to consider its direction. If incoming current I am taking as positive, outgoing current I have to take it as negative. Sir, I'll follow reverse direction. I'll take incoming current as negative. Then you take outgoing current as positive. That is your wish. But both must have opposite direction. If you sum all that, you must get equal to 0. That is KCL, Kirchhoff's current law. And one important point with respect to your examination, that is KCL is derived from law of conservation of charge. Yes, KCL, it is derived from law of conservation of charge. Law of conservation of charge. KCL is derived from where? Law of conservation of charge. So question is not visible clearly, sir. Is it? But for me, on my system, it is very clearly visible, ma. Harika, look at that. Yes. So this is, so maybe this is I1, this is I3. I'm writing for you, and this is I can say I4. This is I4. This current is I3. Yes. No, not I3. It is I2. Yes. Observe. I think it is clearly observable for you, right? Yes, Abhishek Kumar. Current name is not visible. Okay, fine. I'm giving. So I'm giving it. Let me give it again. I'll give it clearly. Question. Yeah, everything is visible very clearly, but current name is not clearly visible. Don't you worry. I'm writing it again. Okay, this is I1. This is I3, ma. This is I4. This is I5. This is I6. And this is I2. Yes. Something is missing. I1 is there, I2 is there, I3 is there, I4 is there, I5 is there, I6 is there. Yes, nothing is missed. So this is node A. At node A, you tell me. Now it is visible to you, right? All of you? Yes. Current name is not visible. I wrote all the currents. Total 6 currents. But there is no scope for the seventh current. Nah? Why that fellow? Yeah, this is I7. Sorry. This is I7. Sorry. Yes, this is I7. Perfect. Perfect now. The question is perfectly visible to every one of you, right? Now tell me the answer, please. Simple question, very simple question. You don't have to struggle at all. At node A, let me write. At node A, come. At node A, I1 is coming. I4 is also coming. That must be equal to what is that is leaving? I3. Let's take this one as I2 ma, instead of I3. This is I2. Let's take this one as I3. I1 is coming, I4 is coming, I2 is leaving. I2 is leaving at node A. Yeah, you see, at node A, I1 is equal to, sorry, I1 plus I4 is equal to I2. Statement 1 is correct. Statement 1 is correct, right? Next, at node C, come to node C. This is node C. I5 at node C, I'm writing here. At node C, I5 is coming. Yes, that is equal to I6 plus I7. I5 is equal to I6 plus I7. Statement 2 is also very much correct. Let's look at node B. This is B for Bombay, node B. At node B, let me write here. Yes, at node B, yes, I3 is coming, I2 is also coming, but I5 is leaving. So you see, I3 plus I2 is equal to I5. I2 plus I3 is equal to I5. Yes, I'm checking your chat box answers. If any one of you answered, yes. Yeah. So this is also correct. One, this is option 1, this is option 2, option 3, option 4. 1, 2, 3, all 3 are correct. 1, 2, 3, all 3 are correct. Yes. Yes or not? All 3 options are correct. Yes, Harika. Perfect. Next. 1, 2, 3, 4. Which of the following statement is correct regarding the permittivity of medium in Coulomb's law? This question is about Coulomb's law. Okay, what Coulomb's law says is, if there are two charges, and I forgot to give you one point here, KCL is derived from law of conservation of charge, KVL is derived from law of conservation of energy. Yes, KVL is derived from law of conservation of energy. Anyone can comment what is KVL? Anyone can comment? Yes. Yes. Yes, KVL, please. I'm checking your chat box. What is KVL? Please type. Yes. What is KVL? Yes, somebody answered. In any loop, yeah, in a loop, overall voltage is equal to 0. Okay, Satyam Sinha. Abhishek Kumar, in any loop, sum of voltages rise and drop is equal to 0. Okay, the algebraic sum of voltages and voltage drops in a closed loop is 0. See, all of you are correct, but the more precise way is, more simple way is, sum of all the voltages, it may be drop or rise or whatever it is, sum of all the voltages in a closed path is equal to 0, but you must follow sign convention. What is sign convention? Whenever current enters at a resistance, the entering point is taken as positive, the leaving point is taken as minus. For a source, there will be plus and minus. So you must write the voltages, sum of all the voltages in a closed path, any closed path it is, by following sign convention, right? And it is derived from law of conservation of energy. Law of conservation of energy. Okay, please do remember that point. Let's go to the next question. Which of the following statement is correct regarding the permittivity of medium in Coulomb's law. What is Coulomb's law? There is a charge called Q1 here. There is another charge called, just a minute, there is another charge called Q2 here. The distance between these two charges is, let's take R. Then the force between those two charges, F, is equal to some constant K into Q1 Q2 by R square. Yes, this is Coulomb's law. Yes, the force between two charges, any two charges, is K into Q1 Q2 by R square. That K is nothing but 1 by 4 pi epsilon naught. That epsilon naught, or let's keep it as K only, do not expand it. So K is going to depend upon permittivity. K is going to depend upon permittivity, or you can write it as 1 by 4 pi epsilon naught also, no issues. What is saying? What is the question? What are the options? The permittivity of the medium is also called as dielectric constant. The permittivity of a medium is epsilon is equal to epsilon naught into epsilon r. Yes. So K, I told you, na, 1 by 4 pi epsilon, 1 by 4 pi epsilon. Yes. So epsilon is called as permittivity. Epsilon is called as permittivity. Yes, it is going to depend on the material that is there between those two charges. You taken two charges Q1 and Q2. Between those two charges, whatever that is the medium is there, that is going to depend on the medium. And in fact, dielectric constant and permittivity can be exchanged, interchanged often, and that is equal to epsilon naught into epsilon r. Epsilon r is called as relative permittivity, and epsilon naught is 8.85 into 10 to the power of minus 12 farad per meter. 10 to the power of minus 12 farad per meter. The units of that epsilon naught are very, very, very important. What it is? Farad per meter. Right? So what is the option correct? That is both 1 and 2. Both 1 and 2. Yes, dielectric constant and permittivity are often interchangeably used. Okay, right. Next question, please. Yeah. So this is regarding transformer. This is regarding transformer. On the this question is on the testing of the transformer. Testing of the transformer. Read the question, please. All of you, read the question. What the question is? Yes, yes. Though I am not visible, but I am audible. Okay, clearly. Yes, I am audible very clearly. Answer to the question, please. What is saying? Short circuit test. This test serves the purpose of determining the series parameters of a transformer. Right? Second statement is no load test or open circuit test. The purpose of this test is to determine the shunt branch parameters of the equivalent circuit of the transformer. Yes. Tell me which one is correct. Both the statements are correct. Either of those two is correct. If either of those two is correct, which one is correct, or both are wrong? Yes. Please convey your answer in the chat box. Yes, yes, yes. Harika, Achyut. Yes, all of you. Come on, I'm waiting for your answer, man. Yes, it is both 1 and 2. It is both 1 and 2. Both are correct. Both are correct. Let me explain about the OC and SC test. Many important points also I'll give here for OC and SC test. Observe. Observe. First of all, see, this question is already given in the next paper. We may not expect, but this question may be asked in the next paper. Maybe on which side SC test is conducted, on which side of the transformer OC test is conducted. Yes, we have two sides of a transformer. Yes, Navalesh Kumar and Harika. One is HV side and another one is LV side. So this is the transformer. First of all, let me answer this question, then I'll go for that question. Transformer is having series branch parameters like this and shunt branch parameters like this. Okay. Yes. I'm taking primary side as HV, secondary side as LV. Yes. Yes. And this is R1, this is JX1, this is R0, this is JX0. This is the voltage E1. This is the input voltage VIR. Let's take it as V1, primary side. Okay. And this is the induced EMF E2. And this is the secondary voltage V2. This is R2. This is JX2. Right? Yes, that is a transformer. Clearly, look at here. Look at here. R1, JX1, R0, JX0, E1, E2, R2, JX2, and V2. If you want to get these parameters, then those can be obtained by using short circuit test. Short circuit test. Series branch parameters will be obtained by short circuit test, whereas shunt branch parameters are obtained by open circuit test. So both 1 and 2. 1, 2, 3, and this is 4. Both 1 and 2 are correct. Both 1 and 2 are correct. So that is everyone know. My question is, my next question. Let me add on white page here, and let me ask one question here for all of you. Yes, for all of you. Yes. On which side? See, OC test must be conducted which side of transformer? I'm not writing the complete question. Which side of transformer? Next, SC test must be which side of transformer? Yes, please comment. Comment. Yes, yes. Achyut, Harika, Satyam Sinha, Abhishek Kumar, Navalesh Kumar. Right? Yes, yes. Comment, please. Comment your answer. On which side of the transformer OC test is conducted, and it is why. OC test is conducted. See, OC test is conducted on low voltage side, LV side of the transformer, and SC test is conducted on HV side of the transformer. Why? Reason I will tell you. Reason very clearly I will tell you so that you will remember. See, in your HPCL examination, reason may not be asked, but we have to know the reason. Then only we will remember. Otherwise, we'll commit mistake. What is the reason? See, HV side, the voltage is high. The voltage is high. You are doing which test? No load test. See, first time I'm talking about OC test or no load. OC test or no load test. No load. During no load, the current is no load current I0 is very small. It's very small, right? Yeah, the no load current is very small. Current is very small. This is HV, this is LV. If you conduct a no load test on HV side, I0 as V is high, I0 is further very low. Our ammeters may not recognize that small amount of current. If I'm conducting the same on LV side, as voltage is less, then no load current is high, then my ammeters are able to measure that current. So to get some good amount of current in OC test, why? Because in OC test already the current is less. We conduct this OC test on LV side, not on HV side. Clear? Yes. Acknowledge me. Acknowledge me. If you are not clear also, you can ask me. Yes. Next. SC test here, HV and LV. Observe. SC test, short circuit test means you are short circuiting the load. You are short circuiting the load. If you conduct on LV side, as voltage is less, short circuit test means already current is very high. Then current is going to be further high. Winding may damage. Yes. Short circuit test, if you conduct on LV side, first of all, in short circuit test, as you are short circuiting the load, current is going to be very high. If you conduct that on LV side, low voltage side, as voltage is low, current will be further high. Equipment may damage. If I conduct on HV side, voltage is high, then current, short circuit current magnitude will be low compared to this one. See, you may think, sir, current voltage magnitudes are changing, then If we connect either of the side, the result is going to be same. Yes, result is going to be absolutely same. You conduct the test on HV side or LV side or LV side or HV side, results are going to be same. Results are not going to change. See, the test is just like, suppose if I want to measure its length, either you take a scale of 30 centimeters, scale of 60 centimeters, or you take very big measuring instrument, whatever it is, its length is going to be constant. In the same way, if you want to find the series parameters and shunt parameters, for that you're going to conduct for series you're conducting SC test, for shunt you're conducting no load test or OC test. You connect on primary side or secondary side, result is going to be same. But we are looking for our convenience, not only our convenience, we are looking for effective method, right? Let's go for the next question. Which of the following is correct regarding transformer oil? As I told you, transformer oil is very, very important concept. Why? Because almost in 3 papers, 2 times this question is given about transformer oil. What is saying? Oil is used in transformer is mineral origin and is extracted from natural petroleum. Okay, this point is very much correct. Second, the electric strength of oil depends almost entirely on its freedom from moisture and suspended fibrous particles, and a test of electric strength is virtually a test of purity of this respect. Yes, very much correct. See, in the oil, yes, somebody asked some question, let me address it. Sir, in YourPedia app, not available lecture downloading question and video quality option. See, please contact Gaurav Sharma, please contact Gurvinder sir. Okay, you will find his number on YourPedia website, Gaurav Sharma. Okay, yes, you will get your problem will be solved. Okay, sir will address that. Fine. See, the dielectric strength, both are correct. See, oil used in transformer is mineral origin and it is extracted from natural petroleum, and it is going to be very good dielectric strength if it is free from, if the oil is free from moisture and all. Okay, so both 1 and 2 are correct. Option is C. Let's go to the next question. You see, statement wise questions, how many questions they given? Too many number of questions, both 1 and 2 like that. Almost 20 questions of same kind they given, right? Read this question, please. All of you read this question. A nuclear power station is just like a thermal power station in which a nuclear reactor replaces the steam boiler. Steam boiler, right? Yes, it is. The only difference between thermal and nuclear, see, there are a lot of differences, means equipment, a lot of things are there. But operation wise, I'm saying, in thermal power station, you are taking coal, you are burning it, then you are getting the heat. With that heat, you are boiling the water, you are getting steam. That steam you are asking to heat the you are directing to hit the turbine blades. Turbine is going to rotate. That rotating turbine is connected to generator, synchronous generator. Synchronous generator is rotating. You're getting the EMF. You're getting the power. In nuclear power station also, you take the nuclear material. Nuclear fission is used, not fusion. So this is one important point. We have 2 types of nuclear reactions, fission and fusion. But nuclear fission is used in our nuclear generating stations. So with the help of nuclear fission, this nuclear material is going to provide you energy. That heat energy you are going to use for heating water, then you're getting steam. Again, the steam is going to hit the turbine blades. The same process, right? So statement 1 is perfectly correct. Next, the fundamental process in a nuclear reactor is chain reaction of a fissile material. Fissile material. Yes, both are correct. Both 1 and 2 are correct. Option is A. B, C, D. Option A is perfectly correct. Yes, option A is perfectly correct, right? Next. This is also you see statement wise only. This is a good question. Okay, please read it. I'll answer it. Please read it, all of you. What is that question? Yeah, questions are perfectly visible. Okay, everything is perfectly visible and I'm audible very clearly. Type your answer in the chat box. The question is, transient response of an electrical circuit can best be described by a linear differential equation. You know, I told you some mathematics are also important, like Laplace transforms and differential equations. This part I will be covering in networks class. Okay, I'll be taking network analysis. In network analysis part, I will be covering the basics of Laplace and differential equations. See, all those things I'll cover. What is the first statement? Transient response. Yes, very much yes. Suppose, what is the proof for that? What is the proof for that? Observe here. I'm taking one simple circuit like this. I'm taking one simple circuit like this. This is R, this is L, this is switch which is closed at t is equal to 0, and this is V, and this is V. So this is plus, this is minus. I'm writing KVL for this one, minus V, and the current I'm assuming it as I of t, minus V. I'm starting here minus V, plus R into I of t, plus L di of t by dt is equal to 0. This is an example of transient circuit. Yes, in this circuit transient happen. That circuit, yes, transient is going to happen. I'm describing that circuit with help of an equation. That equation is a linear differential equation. One must know the difference between linear and non-linear differential equations, right? That is a linear differential equation. Okay. Yes, linear differential equation statement 1 is perfectly correct. Next, Laplace transform is a powerful method of solving linear differential equations. Yes, very much yes. If I ask you to also solve this equation, every equation, differential equation, in fact, every differential equation is going to have two solutions. One is complementary function, another one is particular integral. Headache process. If I apply Laplace transform to the existing one, then within one step I'm going to get the answer of both the both the particular integral and a complementary function. I need not to find separately. Solving a differential equation in time domain is very difficult. That's why we are converting the differential equation from time domain to frequency domain. The tool which is used to convert a time domain equation to frequency domain is called as Laplace transform, right? So network analysis transient we are going to study with Laplace transforms mostly. We can do with help of time domain also, but time domain is damn difficult, lengthy, time taking, right? And one thing you have to keep in your mind that this Laplace transform is applicable only for linear systems. Linear systems, right? Yes, yes. Sir, in every statement type question, both option is correct. See, Satyam, maybe in this paper it is like that. Don't think that that is going to be always true. Okay, that's not see, yeah, everyone can observe that in all the two statement questions both 1 and 2 are correct. I do agree that, but that is an unnecessary input for us. Okay, for us concept is important, not sir, in all the questions both 1 and 2 are correct, therefore in the next examination also if 4 questions are both 1 and 2 correct, in the 5th question though I do not have clarity, I'll tick for that, I'm going to get the mark. That is just like throwing a stone. It may hit the target, may not hit the target, right? So please, yes, yeah, it is a coincidence. Very good. Yeah, that's what I'm saying. It's a coincidence. Come on, next question. Next question. Yeah, this is from power electronics again. Yes, I want answer from you guys for this question. Do it and solve. Solve it and tell me the answer, please. All of you, solve it and tell me. Yes, I'm reading the question. Question is very clearly visible. Okay. A step-up chopper is used to deliver load of 400 volts from a 200 volts DC. You know, that fellow is stepping up the voltage, right? From 200 to 400. If the blocking period of the thyristor is 80 microseconds, compute the required pulse width. Compute the required pulse width. First of all, one must have the formula of step-up chopper. One must have the formula of step-up chopper. Yes. Yes, yes. What is the formula of step-up chopper? Yes, yes. Output voltage V0 is equal to alpha by 1 minus, sorry, 1 by 1 minus alpha, not alpha by 1 by 1 minus alpha into input voltage Vi. So V0 is equal to 1 by 1 minus alpha into Vi is 200. For this one to be 400, 1 minus alpha must be 0.5. So alpha is equal to 0.5. What is alpha? T on by T off. Right? That is equal to 0.5. Yes, yes. Alpha, see, T on plus T off, please. alpha is duty cycle, T on by T on plus T off, that is equal to 0.5. So if see that fellow saying yes, it is 80 microseconds, 80 microseconds. Therefore, see, simply this should be 160. For this total will be T on is 80, then therefore this should be 160, for this one to be 0.5. Therefore T off also should be 80 microseconds. 80 microseconds. A, B, C, D. Option A is perfectly correct. It is 80 microseconds. Harika, you are giving the total T on plus T off, but he is asking what blocking period means. T off, no, blocking period means T off. T off should be 80 only, right? Option is A. Yeah. Next question, please. All of you read. Yeah. This is about Laplace transform. I told you, na, some questions on mathematics also they given, but only from differential equations and Laplace transform, right? What is the question? Which of the following is correct regarding Laplace transform? Laplace transformation also provides the direct solution of non-homogeneous differential equations. First of all, anyone can type in the chat box what is a non-homogeneous and homogeneous differential equation. Yes, yes, yes. Anyone can type what is a non-homogeneous and homogeneous differential equation. Come on. See, I will tell you, please note down this one, the difference between homogeneous and non-homogeneous. If a differential equation is having input, then it is non-homogeneous. Homogeneous means it is not going to have input. Means if you go for circuits, no, without input also circuit can work due to its initial conditions. That comes under homogeneous. There is an RC circuit. Listen, please, all of you. There is an RC circuit. Yes, RC circuit where the input is not there. The circuit is working only with its initial conditions. It is called as homogeneous. If I am giving some input also, that is called as non-homogeneous. Yes, differential equation will give for both. Sorry, Laplace transform is going to give the direct solution of both. Next. This method automatically takes care of initial conditions without necessity of first determining the general solution and then obtaining particular solution. Yes, that is the advantage of Laplace transform. I told you, na? In time domain, if you want to solve differential equations, two times you have to solve, one for particular integral, another one for complementary function. But if you apply Laplace transform, directly you are going to get the solution without taking care of initial conditions and all. Yes, here also both 1 and 2 are correct. Satyam, 1, 2, 3, 4. You see, statement type questions are how many are there, right? Next question. Yeah, efficiency of the transformer. You must answer this question. Yes, I'm waiting for you for your answer in the chat box. Yes, what is the when maximum efficiency of transformer is going to happen? When maximum efficiency of the transformer is going to happen? Yes, yes, that's what the question he given. That's what the question he given. Yes. Come on, Harika, Satyam, Abhishek saying B, Satyam Sinha saying B. Yes. Harika also saying option as 2. Yes. See, variable loss into fixed loss is equal. Every transformer is going to have two types of losses. One is copper losses. Copper losses are also called as variable losses. Variable losses. Next, what is the first option? And iron losses. Second type of losses are iron losses. Iron losses are also called as fixed losses because these are not going to depend on load. Fixed losses, right? Variable ohmic loss into fixed core loss is equal to 1. No. Ohmic loss is equal to fixed core loss. Option B is correct. But if I would have, if I am giving the paper, then I will give you like this. The same option. Variable loss is equal to fixed loss. Another statement is fixed loss is equal to variable loss. Tell me, both are correct? See, both are correct or First one is correct or only second one is correct? Yes. We know that maximum efficiency of a transformer is going to take place if copper losses and iron losses both are equal. But I given here variable loss means copper loss, fixed loss means iron loss, iron loss, fixed loss means iron loss, iron loss, variable loss means copper loss. Tell me, among these 1 and 2, which one is correct? This is very important. This is one very important. Abhishek Kumar, yes. Variable loss is equal to fixed loss. Why? Because see this one in power systems also we see the condition for maximum voltage regulation, that is theta is equal to delta. Sorry, delta is equal to theta. I told wrongly. Delta is equal to theta. We'll see that later in power systems. Okay. Delta is load angle which is varying. Theta is constant, which is transmission line impedance angle. Always we have to write variable is equal to constant. Just like x is equal to 2 is correct, but never you can write 2 is equal to x. What is x is equal to 2? I am assigning this 2 to x. X is a variable which can take any value. X is a variable which can take any value, right? But 2 is already a fixed value. You can't assign some variable value of x to 2 because its value is already fixed. You can't change it, right? This is correct. This is wrong. So that's why variable loss is equal to fixed loss is correct. Let's go to the next question. Which of the following method is the method of measurement of high resistance? Direct deflection method, yes. Third one, I told you previously, we don't take it, but this fellow asked, you see. That's what I'm saying. Total 3 methods I told you. I didn't listed the third one. Let me go to the slide, very first or second one. Yes, here I did not wrote it, but I told direct deflection method. Measure loss of charge or direct deflection method. Let me list out. Next one is also mega ohm bridge method. Mega ohm bridge method. You know, I thought that direct deflection method is not important. Megger and loss of charge mostly we'll prefer, but that fellow is asked about direct deflection method also. You see, remember, see, so from that question, what it is evident for us that that fellow may ask anything. So he is not having anything like important or unimportant. He is not having anything like important or unimportant. So you people also, whatever you come across in the subject, you try to remember it meaningfully. Do not mug it. If you mug, you will forget. Yes, Harika is saying option is 4. Direct deflection and mega ohm. Yes, both are correct. Option A, B, C, D. Same paper. You see, same paper about measurement of resistance only. 2 questions are given. You see? Yes. Next question, please. Yeah. Which of the following pair is correct? This is about induction motor. Squirrel cage induction motor maintenance is very low. Slip ring induction motor maintenance is high because there are brushes. Tell me, what is the basic difference between these two motors, squirrel cage induction motor and slip ring induction motor? What is the basic difference between these two motors? Yes. People are, see, must answer. I am giving not only answer for the questions that those were asked. I am covering concepts also which are required. Maybe 1 or 2 questions will be definitely asked in your examination in the upcoming 2024 this HPCL examination from our today's discussion itself. Slip ring induction motor, there is no provision to add resistance in the rotor. What is the purpose of adding resistance in the rotor? To control the torque. That is one of the method. So with that we can get a very high initial torque. But if you want to introduce resistance in the rotor, definitely there should be some provision. With help of brushes we are doing all this. Right? So squirrel cage induction motor is not going to have any brushes. It is very easy to introduce. It is very easy to maintain it. No wear and tear, nothing is going to happen. Therefore, squirrel cage induction motor maintenance is very low. Slip ring induction motor maintenance is high because there are brushes. Yes, as there are brushes, yes, its maintenance is very high. Its maintenance is going to be very high. Yes, as there. What is the purpose of brushes? The purpose of brushes is to introduce resistance into the rotor. Resistance into the rotor. resistance into the rotor. So both 1 and 2 are correct here also. A, B, C, this is D, right? Let's read the next question. Delta to star, star to delta is also very important. Yeah, what is the purpose of initial resistance to introduce? Achyut, yes, for getting good starting torque. Okay, for getting good starting torque. Starting torque is going to depend upon, starting torque of an induction motor is directly proportional to resistance of the rotor. If I introduce some external resistance, if I'm increasing this external resistance, starting torque is also going to increase. That's the reason why. See, you can remember this equation now itself. Maybe in the next examination about that equation he may ask a question, right? Yes. Then what is the next question? The next question is about if the resistance in delta connected resistive network R1, R2, R3 as shown in figure R1, R2, R3, what will be the resistance Rx in the equivalent network look like? So this is R1, this is R1, this is R2, this is R3, this is X, this is Y, this is Z, this is X, this is Y, this is Z, this is Rx, this is Ry, this is Rz. Now Rx is equal to dash Rx. So Rx means I'm going to get here, I'm getting here. What is this? Multiplication of the connected, multiplication of the connected arms. So here you are getting Rx, this is Rz, this is Ry. Rx is equal to connected product, means what? R1, R3 by total R1 plus R2 plus R3. Yes, delta to star I'm doing, delta to star. Okay, connected arms product by the total. Suppose, sir, I want Ry. What are the connected arms here? Ry connected arms are R1, R2 by R1 plus R2 plus R3. What is Rz? Rz connected arms R2, R3 by R1 plus R2 plus R3. Done? Come here. So is asking Rx is equal to R1. What are the connected amps? R1, R3, please. It is R1, R3 by R1 plus R2 plus R3. Option is B. A, B, C, D. So here you must remember. Star to delta also. Star to delta also, just like that, very simply I'm going to tell you. This is star, suppose. I want its delta. I want its delta. Put like this. You take, this is R A you take, R B you take, R C you take. So this is R A B you take. This is R B C you take. This is R A C you take. So what is R A B? So R A B is equal to sum of the connected elements RA plus RB plus product of the connected elements RA RB by opposite, it is RC. By opposite, it is RC. Right? Sum of the connected plus product of the connected by opposite. Now, sir, I want RBC. RBC is equal to RB plus RC plus RB into RC by RA, right? Let's go to the next question. One more question on Laplace. You see how Laplace. The paper is following some pattern. They are asking too many questions on the same topics what they are asking. So, sir, which topics they concentrate, we don't know. Therefore, every topic you prepare thoroughly. Okay, all directions without leaving. So, Laplace transform of exponential function is described by. Laplace transform of some exponential function is described by. Laplace transform of f of t is equal to integral of f of t into e power minus st dt, e power minus st dt, right? So e power minus st is the kernel that is used to convert from time domain to frequency domain. So option is A, B, C, D. The option A is perfectly correct. Option A is perfectly correct, right? Let's go to the next question. Again, question on Laplace transform only. Yeah. Which of the following is stated as final value theorem? Do not look at the options. What is final value theorem? Final value theorem, I have time domain and frequency domain. In time domain, suppose if you take any function f of t, its a final value is limit t tends to f of t will give you final value. In time domain, f of t means it is going to become f of s, and limit time domain t, frequency domain is going to become s. S tends to, time is tending to 0. You know, time and frequency both are inversely proportional. If frequency is increasing, time will decrease. As time is tending to infinity, s will tend to 0. But one thing that extra comes is s into f of s. This is final value. And these two must be same. These two final values must be same. Either you do in time domain or in frequency domain, answer must remain same. So the option is limit s tends to 0, s into f of s is equal to limit t tends to infinity, f of t. Option is 4. 1, 2, 3. This is 4. Right? Yes, yes. Preeti Kumari, Abhishek Kumar, Harika. Yes, very good. Correct answer. Correct answer. Simple question it is. Yes. Next question. This question we solved. We are done with already this corona. That is 1. This is 2. This is 3. This is 4. Yeah. What is saying? Corona loss is directly proportional to, yes, it is f plus 25. I don't know why it is not writing clearly here on this page. F plus 25. Option is 4. Option is 4. F plus 25. I clearly given you the formula of corona loss in the class. We discussed the corona loss already. F plus 25. Maybe question may be asked next time. Question may be asked this way, ma. Preeti and Harika. Question may be asked this way. At a frequency of 50 hertz, if this much is the power loss, corona loss. If the frequency is rise to 75, what will be the new power loss? So what will be the next page I'll write here, or I'll introduce one white page here, because the previous page is not working properly. That's why. So the question may be asked like this. Corona loss is directly proportional to f plus 25. Therefore, corona loss 1 by corona loss 2 is equal to f1 plus 25 by f2 plus 25. Right? Use this relationship. You are going to get for any frequency corona loss, if corona loss at what one frequency is given to you. Right? The next. Yeah. Which of the following statement is correct about slip ring induction motor? Yeah, starting torque is higher and 3 times that of full load torque approximately. Yes, starting current is lower and it's 2 times that of full load current. Starting current is lower. Yes, yes. Satyam Sinha. Now you tell me, both 1 and 2 are correct, or only 1 is correct? Which of the following statement is correct about slip ring induction motor? Yes, slip ring induction motor, we can control the current. We can control the current with help of resistances. We are going to introduce some resistance in the rotor. Due to that, we can get its starting torque to be very high, and we can control its starting current. Therefore, 1 and 2 both are correct. 1 and 2 both are correct. Very good, ma. Achut, Harika, and Preeti Kumari. Starting torque is higher and it is 3 times of full load torque. Starting current is lower and it is 2 times of full load current. See, it is 2 times of full load current. It is lower, that we are making it low with help of what? Resistance. But squirrel cage induction motor, if you take, there is no one to control the starting current. Therefore, current is very high in the starting. Right? Next question. Which of the following statements is correct? Achut, it is not C. It is 4 only. It is 4. Both are correct. Both are correct. Starting current is low when compared to squirrel cage induction motor, but it is still 2 times more than. See, in any motor, starting current is very high. It is 20-30 times more than that of full load current. Okay, but here with help of resistance we are controlling the current, and we are making the starting current is only 2 times more than that of full load current. Achut, you got my point? Yes, please acknowledge in the chat box. I'll go further. Next question. Which of the following statement is correct about capacitors? The capacitor sometimes referred as condenser. Yes, it is a simple passive device that is used to store electricity. Yes, it can be used to store electricity. It can be used as filter. There are a lot of applications of capacitors. Okay, statement 1 is correct. Next, due to insulating layer, DC current cannot flow through the capacitor as it blocks it, allowing instead a voltage to be present across the plates in the form of an electric charge. Here also both 1 and 2 are correct. See, capacitor allows, capacitor blocks DC. Capacitor blocks DC. We know that, right? Here also 1 and 2 are correct. Next. What is the SI unit of permittivity of the medium in Coulomb's law? Yes. What is epsilon units? Farad per meter. Why? Epsilon not into epsilon r. Epsilon r is not having any units. Epsilon not units are farad per meter. I given you already. C is equal to epsilon a by d. C units are farad. Epsilon not into epsilon r. A meter square. Distance meter gone. It is not having any units. Epsilon not units are this side. It is farad per meter. Option is 4. Yes, 1, 2, 3, 4. Option 4 is very much perfectly correct. Next question. Read it. Which of the following statement is correct regarding mesh analysis? Read it and let me know the answer, please. All of you, read it and let me know the answer. The mesh current analysis technique is applied for all networks with independent sources or networks with dependent sources where the controlling variables are not part of the network under investigation. Read the statement carefully. Somewhat good statement. The mesh analysis technique is applied for all networks with independent sources or networks with dependent sources where controlling variables are not a part of the network under the investigation. See, for any circuit, irrespective of KV, irrespective of it is having dependent or independent, whatever it is, KVL, KCR are applicable. Otherwise, that is not a practical network. It won't exist, first of all. Right? Next. If the controlling variables is part of the network being examined, additional care must be taken when applying the mesh current analysis technique. Yes, we have to take additional care, otherwise we will commit mistake. Yeah, because when you're writing, suppose some alpha is, there is a current dependent current source, alpha into I. Where that alpha is, from where that is coming, we have to see. From where that is coming, we have to see. Right? Yes? Yes or not? Here also both 1 and 2 are correct. Yes, if the controlling variables is part of the network being examined, additional care must be taken. Yes, additional care must be taken. That's all. Okay. Next question. The ratio of voltage across whole string and the product of the number of units and voltage across the unit nearest to the line conductor is known as, what is saying? The voltage, the ratio of voltage across the whole string means V1 plus V2 and so on, Vn by product of number of units, n units, into voltage across the nearest string, that is Vn. This is nothing but string efficiency, string efficiency of insulators. It is string efficiency into 100 will give you percentage string efficiency. Yes. So I'm going to discuss insulators also in power system, overhead line insulators, underground cables, these things. Okay. Very detailedly we are discussing. Yes, Harika and Satyam Sinha and Achyut, these people are attending my classes. Shivam, attending classes. Very thing in detail I am discussing in class. Okay. Next. Dash is a measure of closeness in shape between a waveform and its fundamental component. Harmonic factor. Yes, harmonic factor. Or in fact, I can say it is total harmonic distortion. Total harmonic distortion, THD. See, if you have pulse modulation is not correct, pulse factor is not correct, harmonic factor is not, we didn't see. THD we saw in power electronics. Suppose if you have this fundamental and this is your actual waveform, I can make this non-sinusoidal waveform into sum of sinusoidal waveforms of different frequency that is given by Fourier series. Total harmonic distortion is going to give the deviation of fundamental from actual waveform. So total harmonic distortion, that is THD, option 4. Next question. In slip ring motors, the starting torque is dash, slip ring increased, and the starting torque simultaneously increased. Both are increased. Yeah, we saw this one number of times. This is 1, 2, 3, 4. Induction motors also very good questions they given. Very good number of questions. The purpose of this starting current, no. Starting current is reduced, please. Starting current is reduced and torque is increased. Sorry, it's my overlook. The purpose of adding that external resistance in series with the rotor is to decrease the starting current and increase the starting torque, right? Option is 3. Next, which of the following is the method of measurement of low resistance? Yes, I told low resistance can be measured by using Kelvin's double bridge, and by using potentiometer also you can measure, by using potentiometer also. Okay, not too low, but low resistance, right? Next question. Which of the following is known as a spool insulators? See, another name for spool insulator are Schockel insulators. Schockel insulators are also called as spool insulators. We'll see this point also in what is a Schockel insulator. See, at road curvatures, railway crossings, at that point we are going to use Schockel insulators. Fine. Next question. Which of the following is the advantage of HVDC transmission? Yes. So somebody asked some question, Abhishek Kumar, sir, when we will get e-books for question practice on YourPedia panel? Soon you will get. Okay. I think please check, Abhishek Kumar. By this time already those e-books might have been added. Okay, please check. You'll get the information. Which of the following is the advantage of HVDC transmission? Rapid change of energy flow, negligible sheath loss, skin effect. All 1, 2, 3. Why? See, skin effect is there only for AC. We discussed skin effect. I given you the formula, skin depth and all. Skin depth delta. Okay, delta is equal to under root of 2 by omega sigma mu. All these things I given. No skin effect. No sheath loss. If you take a cable, underground cable, there is a part called sheath, metallic sheath, which is made up of lead to avoid moisture into the cable. Yes, in that, because of the frequency, sheath loss is going to happen. That is not going to be there. Yes, this is correct. Rapid change of energy. Yes, rapid change of energy. That is also correct. 1, 2, and 3. 1, 2, and 3. Right? Next question. Which of the following is correct statement? Star connection is also termed as T. Yes, star connection. This is star. Right? If you make it, you can write this way also. Star, one arm of the star, another arm of the star, another arm of the star. Star and T both are same. Delta connection can be named as pi. Yes, both 1 and 2 are correct. Delta is also pi. Why? Delta connection. Yes, this way. Yes, I can put this way also. This is one arm of the delta. This is another arm of the delta. This is another arm of the delta. Delta connection and pi connection both are same. Right? Next question, please. Yes. In the given circuit, determine the number of junctions, junction points, and meshes. Junction points are nothing but nodes. No, junction point is nothing but number of nodes. You see, 1, 2, 3, 4, 5, 6, 7, 8 nodes. Okay, 8 nodes actually. But see, I will tell you one point here. Let me number it again. 1, 2, 3, 4, 5, 6, 7, 8. But these two are treated as same node. Okay. See, and only principal nodes we are considering, not the simple nodes. What is a simple node? See, 1 and 2, both 1 and 8 both are simple nodes. 1, 8 are simple nodes, means there is no current division taking place. That is, those two are neglected. One mesh, second mesh, third mesh. Yes. So among 1 and 2, if we take one node, need not to take junction points. So this is one node, 1, 2, 3, 4, 5, and 6. 6, meshes are 3, but not there in the option. 4, 2 is asking junction points. Junction points are nothing but nodes. Yes, 1 is a node, 2 is a node, 3 is a node. Oh, 3 is also not considered. 3 not considered. I forgot. I see. I in overlook I saw 6 is also not considered. Why? Because simple node. Why? Because in this current is same. Yeah. Now you'll get the perfect answer. Node 1 is not considered. Node 8 is not considered. Node 6 is not considered. Node 3 is not considered. Why? Because they are simple nodes. 2, 4, 5, this 7. Therefore, this is 1, 2, 3, 4. 4 nodes and 3 meshes. 3 meshes. Yes, it is. 4 nodes and 3 meshes. Right? Yes, yes, it is 4 nodes. I didn't saw clearly. I thought that some circuit there. No current division is taking place. Option is B. Next question. Dash are designed to have both controlled turn on and turn off time capability. So both turn on and turn off is having a gate turn off thyristors. Yes, if you go for silicon controlled rectifier SCR, you can turn on, but turn off there is a lot of process for that, right? By using gate channel, you are going to turn it on, but for turn off, not through gate. Okay, we have to apply reverse voltage. A lot of things are there, right? But here in gate turn off thyristors, both turn on and turn off is there, right? Next. The insulating layer between capacitor plate is commonly called as dielectric. This is a direct question. Yes, dielectric it is. That is a direct question. Harika. Yes. Good, Harika. You are answering. Differential relays are commonly used to protect transformers with the ratings larger than. So differential relays we use for more than 10 MVA. Differential relays. So option is this is the theory question. You have to remember. Option is C. Option is C. Next question. A relay that operates on the basis of voltage to current ratio. If you take voltage to current, you are going to get something called as Z. Therefore, definitely that is called as impedance relay. That is called as what? Impedance relay, right? It is an impedance relay, right? Next question. Yes, good question. It is. In half bridge inverter, what is the value of root mean square output voltage? Half bridge inverter. Yes, you're going to get the output of half bridge inverter like this. Yes, half bridge inverter you're going to get. This is V0 by 2. This is Vs by 2. This is minus Vs by 2, right? If you take its RMS value, Vrms is equal to, you're going to get Vs by 2. Vs by 2. So answer is option C. A, B, C, D. Right? Yeah, this is the output waveform of half bridge inverter. Yes, somebody asked some question. Koteshwar Rao, BL project engineering or engineer or project officer advertisement results ఎప్పుడు వస్తాయి sir? Please reply. See, results as election code is recently released, all the results are in queue. Okay, within 1 week or 10 days they will start giving one by one. So it is expected before 15 days, Koteshwar Rao. Okay, yeah. See, half bridge inverter, it is the output of half bridge inverter is like this. If you take its RMS value, any RMS values, if it is a square wave, if it is a full square wave without any discontinuity, its RMS value is same as that of the value, its value. Any means it is having only two levels, plus and minus. Plus and minus both are equal, right? Yes, plus and minus both are equal. Next question. Okay, question answer already mentioned over there, but question is very easy. In frequency domain network having n principal nodes, one of them is designated as a reference node, and we require dash node voltage equations to solve for the desired result. Either it is frequency domain or time domain or whatever it is, n nodes if you have, if one is principal node, reference, then n minus 1 equations we have to solve. So number of equations required to solve any circuit having n nodes and one is designated as reference, then n minus 1. Option is 4. Option is 4, right? Next question. Directional relays are designed to operate for fault currents in only one direction. See, on the directional relay, suppose if this is a relay, I'll put arrow like this. What does it mean by this one? If current is flowing in this way, it won't operate. But if current flows in this direction, it will operate. Why? Because the designated direction is the direction in which current should not flow. Listen, the designated direction is the direction in which current should not flow. So if current is flowing in this direction, relay will operate only in one direction. That is about see, This is about the questions that was asked, good questions that was asked previously in HPCL paper in 2023. We are left with few more questions in the next session. We are going to see those question solutions also. Total 85 questions, almost 45 to 50 questions I solved. Yes, and not just the questions, we are going with the concepts. This series will continue, YouTube series it is. We are going to continue all three papers. I will be discussing 2023, 2022, 2021 for you to provide, I can say, this view on how the questions will be asked in HPCL paper, right? For your preparation, it is going to be very much useful. Attend and forward this link to your friends. Tell them also to join. YourPedia started one dedicated module, tailor-made module, especially for HPCL preparation, and the classes will be exactly in the direction of HPCL examination. Not we are not going to teach unnecessary things. We are not going to waste your valuable time. Okay, 75 days of target. Within 75 days, we are going to, or before 75 days itself, we are going to complete your syllabus. Join your hands with YourPedia to accelerate your preparation for your HPCL written examination. Thank you. If you have any queries, you can contact. You can message to this number 891 9999 705. 891 9999 705. Okay, yeah, we'll meet in the next session. Thank you.